हेलो दोस्तों, मैं हूं श्रीनिवास और स्वागत करता हूं आप सबको मेरे इस चैनल आसान एकेडमी में। तो आज हम एक शानदार जबरदस्त टॉपिक पढ़ने वाले हैं। चैप्टर 1 क्लास 10th केमिकल रिएक्शंस एंड इक्वेशंस। दिस इज द मोस्ट फंडामेंटल चैप्टर इन केमिस्ट्री एंड इट बेसिकली डील्स with all the chemical formulas and their chemical reactions and some equations and what are the types of chemical equations and types of chemical reactions. We all are going to study in detail, bit by bit, from time to time in different parts. So in part 1 in this video I will be going to cover all the details of different ways on how to deal with chemical reactions. Before to that, I will tell you what do you mean by chemical reaction, what do you understand by chemical equations. Before to that, I will tell you the difference between chemical change and physical change. What is the difference between physical change and chemical change? In the physical change, what happens whenever some reaction takes place, that will again be reversible. But in case of chemical reaction, what happens whenever a new product is formed, we never get back the same reactant as it was occurred due to the formation of a product. That means in case of physical change, the reaction is a reversible process, but a chemical change is something that is completely irreversible. That means we cannot obtain the same reactant as it was before. Clear? First point. Second thing, in a physical change is a temporary change which can be altered as when required, but a chemical change is not temporary, it is a permanent. Like suppose we have cooked our food. Will we be able to get the same ingredients as before? Will we be able to get the tomato as it was earlier? No, that's not possible. That is a chemical change. So the cooked food we are unable to get the same ingredient as it was before present. Clear? So यहाँ पे हम देखते हैं कि the difference between chemical change and physical change. And now come to chemical reaction. What do you understand by chemical reaction? A chemical reaction is nothing but a reaction in which two or more substances react, or a single substance gives rise to two or more products. Clear? A chemical reaction is something that two or more reactants combine to form a product or one or more products which cannot be reversible. Clear? This means a chemical reaction is a reaction in which a single product or two or more products are formed from a single reactant or two or more reactants. Clear? For example, we have seen, let's see, milk is left at room temperature during summers. At summers, if we keep our temperature at high temperature or the normal temperature in our surrounding, if we keep the milk as it is, then curd will be formed due to lactobacillus bacteria, as all of you know this. Why this has happened? Due to the action of the lactobacillus bacteria, it releases some amount of acid which reacts with the milk and it converts the reactant into product, that is curd, which cannot be reversed. Clear? Will you be able to get the same milk as it was before? No, that's not possible. That is a chemical change. Clear? Now, an iron tawa pan nail is left exposed to humid atmosphere. That means roasting will happen. Due to humid atmosphere, oxygen will react with the iron objects and it will convert the iron into junk. That is, a roasting of iron takes place which cannot be reversed back. That is, it is a chemical change. Similarly, grapes get fermented, food is cooked, as I gave the example, food gets digested in our body, we respire. All these are chemical changes which we will be studying in detail in our coming sections. Clear? Now, in activity 1.1, this is a very important activity, just go through it. See, this is a Bunsen burner, here a magnesium, this one is a magnesium ribbon. So in this experiment it was given that take a magnesium ribbon, before we use it just rub it with a sandpaper. Why? So question is, why we should rub a magnesium ribbon before we use it? Because if it was present, if the magnesium is not rubbed, then at the present condition what happens? Oxygen is present over the magnesium metal, and which leads to magnesium oxide. So magnesium oxide, the properties of magnesium oxide is different from that of magnesium. So whenever we will do the experiment, we think that we are using magnesium, but instead of that we are using magnesium oxide. So to avoid these circumstances, what we will do? We will cover we will cover the sandpaper, we will rub the sandpaper, we will rub the magnesium ribbon with a sandpaper so as to get the proper magnesium as it is. Now what happens, we will take the magnesium ribbon and we will burn it using the Bunsen burner. After that, what we will see that some dazzling flames are produced out of the Bunsen burner. This experiment shows that what happens, that when magnesium ribbon is burned with a dazzling flame comes out, which indicates that magnesium ribbon burns in the presence of air. Air means here oxygen. Clear? Magnesium ribbon burns in the presence of oxygen to release magnesium oxide. That means this is a chemical reaction. Clear? Why? Because here the reactants are magnesium and oxygen, and the product formed is magnesium oxide. Clear? Okay. Next. This is the first experiment which says that burning of a magnesium ribbon in air and a collection of magnesium oxide in watch glass. Clear? Now, see this statement. Magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Clear? In this experiment, two questions will be asked. What? First question, why you need to rub a sandpaper with magnesium ribbon? Why the magnesium ribbon is rubbed with a sandpaper? Why? Before we use it. Second question, what is the formation? What are the products formed after a magnesium ribbon is burned? Clear? Why a white dazzling flame is produced? All these questions, I hope all of you are very clear about the experiment, and I hope you will be able to write the answer of these questions. Next, activity 1.2 and activity 1.3. Activity 1.2 is very easy. Take lead nitrate solution in a test tube, add potassium iodide solution to this experiment. What will form? A chemical reaction will occur. Lead nitrate solution reacts with potassium iodide to form lead iodide and potassium nitrate. So here what happens? The ingredients are changed from one ingredient comes to the other reactant, and the other ingredient comes to the same reactant. Clear? What happens here? Exchange takes place. Exchange of ions takes place. We will study in detail in the further classes. Now move to activity 1.3. Activity 1.3 says that this is the activity. What happens? This is a conical flask. This is a conical flask. Take a conical flask, and this is the cork we are using here. And what happens? Now, this is the dilute sulfuric acid. This one is your sulfuric acid. In sulfuric acid, what happens? Zinc granules are present. Zinc granules means zinc के टुकड़े. क्लियर? जिंक के टुकड़े अगर कुछ हम यहाँ पे डाल देते हैं तो क्या रिएक्शन होता है, इसके बारे में हम देखेंगे. तो व्हाट हैपेंस? हाइड्रोजन गैस इज रिलीज्ड एज सून एज जिंक ग्रैन्यूल इज इंसर्टेड इनटू द डाइल्यूट सल्फ्यूरिक एसिड सॉल्यूशन. क्लियर? टेक सम डाइल्यूट सल्फ्यूरिक. डाइल्यूट और कॉन्सेंट्रेटेड में डिफरेंस क्या है? डाइल्यूट मीन्स द अमाउंट ऑफ कॉन्सेंट्रेशन ऑफ सल्फ्यूरिक एसिड इज लेस एज कम्पेयर टू द कॉन्सेंट्रेटेड सॉल्यूशन. क्लियर? कॉन्सेंट्रेटेड और डाइल्यूट सॉल्यूशन में डिफरेंस ये है कि डाइल्यूट सॉल्यूशन में जो अमाउंट बहुत कम होता है और एज कम्पेयर टू कॉन्सेंट्रेटेड सॉल्यूशन. क्लियर? आई होप यू आर क्लियर. नेक्स्ट व्हाट हैपेंस? एड सम जिंक ग्रैन्यूल्स टू इट. ग्रैन्यूल्स मतलब टुकड़े, कुछ जिंक्स के ग्रैन्यूल्स ऐड कर दो. उसके बाद क्या होता है? देखो कि यहाँ पे क्या होता है, हाइड्रोजन गैस रिलीज होता है. और हाइड्रोजन गैस रिलीज होने से क्या होता है, अगर वो रिलीज होकर बाहर चला जाएगा, इसलिए हम क्या करते हैं, एक कॉर्क इंसर्ट करते हैं. यहाँ पे देखिए एक कॉर्क इंसर्ट किया गया है टू अवॉइड द release of hydrogen gas. Clear? So in this experiment what happens? Release of gas takes place. That means एक क्वेश्चन आपके मन में आया होगा कि सर हाउ कैन यू नो दैट समथिंग हैपेंड, सम रिएक्शन हैज टेकन प्लेस, सम केमिकल रिएक्शन हैज टेकन प्लेस, हाउ कैन वी सो श्योरली say about this? Clear? There are some criteria to understand this. Let us go through this. Here 4 criteria are given. Change in the state. Change in the state means there is a change in the state, physical state, that is some solid changes to liquid, liquid changes to gas. Clear? This is a change of state takes place. Clear? Second, change in color. In case of some here what happens when magnesium ribbon burns, we have seen that white dazzling flames comes out, that is a change in the color takes place. Evolution of gas, as we have seen here that hydrogen gas is liberated, that means a gas is liberated, that is release of gas. Clear? Evolution of a gas. Or change in the temperature. In some reactions we have seen that the temperature is suddenly changes, that means a change in temperature. So these are the qualities, these are the characteristics by which we can understand that some reaction has taken place, and that means a chemical reaction has taken place by means of change of state, change of color, change of temperature, okay, and evolution of a gas. Clear? These are the characteristics by which we can understand, we can say so surely that some chemical reaction has taken place. Clear? Now next move to chemical equations. So I hope all of you have been clear about what do you understand by chemical reaction. Now we will be further moving to chemical equations. A chemical equation is nothing but the formation of a product from the reactants, and writing down the formulae, writing down in a equation format, this is nothing but a chemical equation. So suppose what happened in our activity 1.1, we have seen that magnesium react with oxygen to form what? Magnesium oxide. That means magnesium plus oxygen, this part will be your reactant, and to arrow mark indicates that some product has been formed, and this arrow mark, see here, this is the arrow mark, this is the arrow mark, this indicates that some formation of products has been taken place. Here magnesium reacts with oxygen to form magnesium oxide, this one will be your product. Clear? And these two will be your reactants. So reactants gives rise to product. This is nothing but your chemical equation. I hope all of you have been clear. Now in LHS, in left hand side we take reactants, and in right hand side we place the products. Clear? Now move on to writing a chemical equation. It is very important part of our chemistry. In class 9th, I hope all of you have been read. I hope you have remembered that you have learnt about the formation of chemical formulae. So in 9th class you have studied that the formation of chemical formula, how calcium and oxygen combine together to form calcium oxide, how magnesium and oxygen combine to form together magnesium oxide. Clear? So this involves the valency and transfer of electron takes place and formation of compound takes place. Clear? And this is the chemical formula. I am not going to tell you these 9th class concepts, because I think you have all been cleared about in previous classes, and now directly I will be going to cover the chemical equations involving chemical formulas. Clear? So first of all, magnesium oxide means MgO. This react with oxygen. Oxygen will be present in which state? In diatomic state, that is O2. तो मैग्नीशियम और ऑक्सीजन ये दोनों के मिलने से क्या होगा? रिएक्टेंट, ये दोनों रिएक्टेंट के आपस में मिलने से एक प्रोडक्ट फॉर्म होगा और उसका नाम होगा मैग्नीशियम ऑक्साइड. सो हाउ टू राइट इज? लेट अस लुक एट हियर. Mg plus O2, Mg plus O2, this will be your MgO. Clear? Mg plus O2 gives rise to MgO. Clear? This one will be your what? A chemical equation. But listen here, in chemical equation what happens? We need to balance both the left hand side and the right hand side. What to balance? We have studied previously that in case of a chemical reaction, the LHS, the amount of substance, the amount means mass, the amount of mass contained in LHS must be equal to the amount of mass contained in the RHS. That means mass means what? Number of atoms. The number of atoms in the LHS must have to be equal to the number of atoms in the RHS section. Clear? So what a new concept comes here, that is how to balance a chemical equation. That means we will now focus on to how to balance the RHS and the LHS. Clear? So next focus on to that balanced chemical equation. Clear? Now balanced chemical equation. So here what we have seen, total mass of the elements present in the product of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Reactants में जितने मात्रा में हो गए मास, उतने ही मात्रा में राइट हैंड साइड में प्रोडक्ट्स में होना चाहिए. क्लियर? Exactly on the same way, we can say that the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Clear? अगर बैलेंस होने से पहले को इक्वेशन को क्या बोलते हैं? उसे कहते हैं कि जो स्केलेटल केमिकल इक्वेशन, और बैलेंस होने के बाद वो परफेक्ट बैलेंस्ड इक्वेशन हो जाता है. क्लियर? तो बैलेंस्ड केमिकल इक्वेशन से पहले उसे हम क्या बोलते हैं? स्केलेटल केमिकल इक्वेशन. क्लियर? Okay. Next, move on to how to balance a chemical equation. So I will solve one question. Now let us see this one. Zn plus H2SO4. I will solve 5 to 7 questions and I will tell you how to draw this, how to balance the chemical equation. So let us see one question number 1. Zn plus H2SO4 gives rise to ZnSO4 plus H2. So here what we have to see? We have to see different atoms. Clear? Now see Zn plus H2SO4. Here see zinc. How many zinc are here? Only one atom of zinc. Here only one, nothing is there, that means one is there. Clear? Only one is there, so one zinc, and in LHS nowhere else zinc is there. Clear? So next go through right hand side and see, check whether only one zinc is present or more than one atom of zinc is present. So here only Zn means only one zinc is present. Clear? That means zinc is perfectly balanced, so no need to worry about zinc. Clear? Now check whether hydrogen is balanced or not. Hydrogen, here 2 H2, so that means 2 atoms of hydrogen is present. So let's check for right hand side, and right hand side also only 2 hydrogen atom is present. That means hydrogen is also balanced. Now check for sulfur. This one is sulfur, so only one sulfur is present. Also here also only one sulfur is present. That means sulfur is also balanced. Now oxygen only here 4 atoms of oxygen are present, and on the same way on RHS also 4 oxygen atoms are balanced. That means it is already a balanced chemical equation. Clear? So it is already a balanced chemical equation. We don't need to change it further. Clear? Now next move on to a next question. Next balance it. Clear? So question number 2, just balance CO plus H2 gives rise to CH3OH. Clear? CO carbon monoxide, H2 hydrogen gas, CH3OH. CH3OH, this is methanol. We will be studying regarding the naming of compounds in carbon compounds. Clear? Chapter number 4, carbon compound, we will be studying in detail. No need to worry about that. Just balance the chemical equation. So before to that, what happens in our book, it has been written that we can take in any way, right? There is no such way that we have to do in this way only. No, not that's not correct. Clear? What we can do, we can go from any side to any side. Clear? So this is a trial and error method to correct to the left hand side and to that of the right hand side. So in book, what happens, for our convenience, we can take the maximum number of atoms present in the element. Clear? So here what happens, the maximum number of atoms present here, we can take it as, here it is how many? 3 plus 1. Hydrogen has maximum number of atoms, that means here 4 atoms has been present. So we can what we can do, we can balance it to that of right hand side. In right hand side, how many atoms are there? Only 2 atoms are there. So we can take it as 2H2. Clear? Remember one thing, you cannot write it as H2. Clear? This is wrong. You have to write it as H2 because this is the chemical formula. This is diatomic state of hydrogen. We cannot change, we cannot alter anything related to the chemical formula. The chemical formula cannot be altered. Clear? Remember that thing. Now what we can do here is, we can add 2 to LHS in hydrogen atom. Clear? So what happens here, the 4 atoms of hydrogen is balanced to that of the right hand side. Clear? It's here 1 atom and here 3, that means 4. Clear? 4 atoms are present, right? Now what happens, let's check for oxygen. Oxygen, here only 1 atom oxygen is present, and here also only 1 oxygen atom is present, so that means it is balanced. Now look at for carbon. So here carbon, only 1 carbon is present, and also here only 1 carbon is present. That means we have made it a balanced chemical equation. So we have converted the skeletal chemical equation to a balanced chemical equation. Clear? Now move on to next question, right? So what happens here, question number 3, H2 plus O2 gives rise to H2O, right? Now check the number of atoms present here. We have got hydrogen has 2 atoms in LHS and hydrogen have 2 atoms in RHS. That means it is already balanced. But here what happens, oxygen has 2 atoms in LHS, but in oxygen has only 1 atom in RHS. That's why we have to balance oxygen atom first. Clear? So here 2 number of atoms are present in oxygen, and we have to multiply 2 to RHS, so that we will be getting our oxygen balanced, right? That means 2 atoms of oxygen are balanced, so 2O. Now what happens? Now hydrogen has been increased from 2 to 4 because 2 into 2 equal 4. So now 4 number of atoms are present in hydrogen. That means we have to balance it in the RHS, sorry, in the LHS, that is reactant side. That means we have to multiply it by 2. So we get 4 number of hydrogen atom, and also here we got 4 number of hydrogen atom and oxygen 2 atoms of oxygen, and here also 2. That means it is already balanced. It has been balanced chemical equation, right? So this question also solved. Now move on to next question. Question number 4. AgCl gives rise to Ag plus Cl2. So in this reaction what happens? Check, this one has Ag 1 atom and chlorine 1 atom, but here chlorine 2 atom. That means we have to multiply 2 in the LHS to balance our chlorine. Clear? And now check that our silver has here 2 atoms, but here only 1 atom is there. That means multiply it by 2. So our silver also balanced 2 atoms of silver, here 2 atoms of silver, here 2 atoms of chlorine, here also Cl2, 2 atoms of chlorine. That means our balanced chemical equation has taken place, right? Now move on to next question. Question number 5. CH4 plus O2 gives rise to CO2 plus H2O. Clear? CH4 plus O2 gives rise to CO2 plus H2O. In this, see here what happens? 3 oxygen atoms are present, O2 and 1 O here. That means 3 oxygen atoms are present. But here what happens? Only 2 are present. That means what we can do? Here we can multiply it by 2. Right? If we multiply it by 2, what we get? Oxygen 2 and here 2. That means 4 oxygen atoms in RHS. So in the same way we can multiply 2 to the LHS to get 4 atoms of oxygen. That means here oxygen is balanced. Do not worry about how to practice. After practicing a lot, you will be getting an idea on to how to write LHS, balance LHS and RHS. Clear? Now just go through it and balance hydrogen. Here hydrogen 4 atoms are present, but here also 4 atoms. It is already balanced. Clear? Now carbon. Carbon, here only 1 carbon is present. Here also 1 carbon is present. That means it is a balanced chemical equation. Clear? Good. Next, question number 6. Fe plus H2O gives rise to Fe3O4 plus H2. Here what happens? Oxygen, see the largest, I have told you that for our convenience we can take the largest number of atoms present. So here oxygen is present in 4 number of atoms are present in oxygen in RHS. So what we can do here? We can multiply it by 4 so that our oxygen is balanced. Now what happens? We can balance hydrogen by, look at your hydrogen 4 atoms are present, 4 into 2, that means 8 atoms are present. So here what we can do? We can multiply it by 4. So our hydrogen is also balanced. Hydrogen balanced, oxygen balanced. Clear? Now iron. Iron, here 3 atoms are present, so we can multiply it by 3. Clear? So our complete equation is balanced. Right? Next, question number 7. FeSO4 gives rise to Fe2O3 plus SO2 plus SO3. Clear? Here see the number of oxygen atoms. Here 3, here 2, 5, here 3, 8, and here 4. That means we can multiply it by 2. 2 4s are 8, and here oxygen is balanced. 3 2 3 8. Clear? That means oxygen balance. Now check for iron. Iron here 2. That means here also 2 iron, and here sulfur 2 sulfur. Here also SO2. SO2, S here 1 sulfur, here also 1 sulfur. So that means 2 sulfur also present in right hand side. That means it is also a balanced chemical equation, right? Next question. PbNO3 whole 2 gives rise to PbO plus NO2 plus O2. Clear? This one, see what happens here. Here Na2 and oxygen is what? 3 into 2, 6. 6 number of oxygen is present and 2 number of nitrogen is present. That means what we can here do, balance oxygen first. Here 2, 2, 4, 1, 5. And here 3 to the 6. That means what we can do here, we can just go for nitrogen or oxygen. Oxygen, what we can do, we can multiply it by 2. Clear? If we multiply here by 2, so it is 2, 2, 2. That means 6 number of oxygen atoms are present. Now, here also our oxygen is balanced. Now, what happens? As it is Pb is also 2, so we can multiply it by 2. Clear? So, as 2 is multiplied here, that means Pb is balanced. Pb is balanced, 2 Pb, 2 Pb. But what happens? Our oxygen changed, nitrogen also changed. So nitrogen, for nitrogen to change, what happens here? Nitrogen 2 into 2, 4 nitrogens are present. That means here also we have to do multiplied by 4. Clear? So our nitrogen is also balanced. Now we have to check for oxygen whether it is changed or it is already balanced. Now what check? 3 into 2, 6 into 2. Oxygen, 12 oxygens are present in LHS. So check for RHS. Here it is 2 oxygen plus here 4 into 2, 8 oxygen plus 2 oxygen. 2, 8, 10 plus 2, 12 oxygen. That is oxygen also balanced. Clear? So it is already a balanced chemical equation. Clear? I hope all of you have been cleared about how to balance a chemical equation. Now a task is, I will give you a task to balance a chemical equation. So write down in your notebook CO2 plus H2O C6H12O6 plus O2 plus H2O. This is in the presence of sunlight and chlorophyll pigments. This is nothing but our photosynthesis reaction. That is taking place in our leaves, in our chlorophyll pigment. In the presence of chlorophyll pigment and sunlight, carbon dioxide reacts with water. Carbon dioxide reacts with water to form oxygen and C6H12O6, that is energy. Clear? So in this reaction, I hope all of you please write it down and mention it in comment section after balancing it. Clear? Balance your oxygen, carbon and hydrogen respectively and put it in your comment section. Clear? Okay, so I hope you have enjoyed today's class. So in the next coming classes, I will be telling you about the different types of chemical reactions that takes place around, and in the next part, in the coming part, I will be covering all the details of this chapter, and our chapter will be finished within 2 to 3 parts max. Clear? So please go through the details in your Ncert syllabus in your first chapter science book, and we will be meeting soon. Okay, thank you.